Okay, this is the last section of the review, number 13. When the reflection of an object is seen in a flat mirror, the image should always be virtual and upright. And the reason is, again, here we have a mirror, here we have an image. When you draw it, it hits, it bounces straight back, so we have a line right there. The second line is here, hits, bounce straight back. The only thing you need to make sure you have is this equal to this. That traces straight back. So the image is always produced as upright and it's virtual. And you know it's upright because you look at yourself in the mirror and you're standing upright. Alright, and you know it's virtual because you can never project your image out onto the out in front of you unless you're like in a horror movie or something. Alright? So number 14. When red light and green light shine on the same place on a white piece of paper, the spot appears to be yellow. Now remember this chart: red, green, and blue. If you're adding light together, you get yellow, cyan, and magenta. So it says we are adding red and green light on number 14. Red and green light, we come down here, and we get yellow. Number 15, which of the following is not a primary color of light? Well, these are the primary colors of light: red, green, and blue. So the only one that's not a primary color in that list is yellow, letter A. So number 15, the answer should be A, yellow, because red, green, and blue are the primary colors of light. Alright, number 16, when the transmission axis is perpendicular to the plane of polarization for light, no light passes through. So if this is this right here, if this is your first lens, this is the transmission axis. So if the light's coming through like this and you turn your polarized lens at 90 degrees to this transmission axis, no light reaches it. Alright? Number 17. When green light mixes with white light, you get D, white light, although it may appear to be pale green. So what will happen is, it looks just like this. It's like this white light is red, green, and blue. So essentially you've got white light and then you've just got a little bit of extra green. You would basically have red, green, blue, and a little bit of extra green, so it might appear a pale green. Number 18, what occurs when light is passed through a red filter is combined with light passed through a green filter? Well, then you have red light coming and hitting, and you have green light coming and hitting, and you get yellow. Alright, red plus green make yellow. What occurs when yellow light is combined with blue light? Well, what is yellow light made of? Well, here is yellow light, and here is blue light. Yellow light, you should see, is made up of red light and green light. And what happens when we add red, green, and blue together? Yes, sir, we get white light. So yellow and blue combined make white light. Alright, number 20. How is the brightness of a source affected by, how is the brightness of a light source affected by distance? It is this: 1 over d squared is the ratio to brightness. So if you're twice as far away, you are 4 times less bright. And if you are 3 times farther away, you are 9 times less bright. Alright? But don't forget that if you are half as far away, you are 4 times brighter, because it would be 1 over 1/2 squared, or 1 over 1/4, which is equal to 4 times. Alright, and then lastly, number 21, last one. A candle is 49 centimeters in front of a convex spherical mirror. Convex spherical mirror. Candle's 49 centimeters in front. There's your candle. Alright, with a radius of curvature of 70 centimeters. Remember that the focus is equal to the radius of curvature divided by 2. May or may not have said that, but I covered it just now, so it shouldn't be on the test, honestly. Don't worry about it. But the radius of curvature is half that. So if the radius of curvature is 70, it might be on the test, actually, now that I'm thinking about it. Ignore what I said. If the focus is equal to the radius of curvature divided by 2, it's a simple thing to remember. So the focus is at 35. So if that is 49, the focus is at 30. And remember, always on a convex mirror, the focus is behind the mirror. And it says draw a ray diagram to find the position and magnification of the image. Well, okay, I can do that. So, but there's the ray diagram. So I know that the ray should be in front of the focus. So the image should be in front of the focus, and I know it should be smaller. But let's get a little bit more precise. Well, let's see. I know that I can solve for it using this formula. Alright, so there we go. We got 1 over P plus 1 over Q equals 1 over F. And so I can fill this in. 1 over 49 plus 1 over Q equals 1 over negative 35. And so if I do that, because remember the focus is equal to 70 divided by 2. Focus is equal to 35. So if I do that, I should get 1 over Q equals 1 over negative 35 minus 1 over 49. And if I do this, I should get that my image would be, is equal to negative 20.4 centimeters behind the mirror. So that works out well. Q should be in front of the image, in front of the focus, which it is, and it should, because the Q is at 20.4 and F is at 35. That makes sense with the drawing. And then let's look at the size difference, right? M should be equal to Q over P, so it should be 20.4 over 49, which would equal 0.4 something, I believe. So if we do 20.4 divided by 49, we would get 0.41 or 0.42. And so that makes sense. Look, it's about a little bit more than twice as big, and so that makes sense with the drawing. All right, so that finishes up the review. I wish you all luck on the test.